All right, so why should we care about uh, how elastic something is? What's the what's the benefit of learning it? Why do we have this particular um, variable that why do people care about it? Well, imagine you are a small business owner and you have a particular price and you want to figure out, hey, like our input costs are increasing, um, and I need to make a pricing decision. Okay, and I'm concerned because if I increase my prices, I might see a shift inwards of demand. I might see the quantity. I should be more precise. I might see the quantity of demand to decrease because I increase my prices. So by how much can I increase my price? Okay. And on the whole, it's going to be determined by the supply function, but each individual business owner is going to be the ones shifting supply function up, um, so that the overall, the supply function is going to be the aggregate of every individual producer making this decision. So you're a small business owner. You're thinking, what should I do? By how much should I raise my product? If I raise it by a lot, am I going to see lower profits because there's going to be less people consuming the good, even though they're consuming it at a higher price? If I raise it by a little, is that enough to cover my increase in cost, even though I'm not losing too many customers, right? Well, elasticity tells you how much demand shifts inward when you increase price, right? So if you have a perfectly inelastic good, demand shouldn't change at all. So you can just continue raising the price and just see more and more revenue from that, okay? Or more and more price times quantity. So more, that's what the definition of revenue is. It's your essentially your profit before you factor in your cost. So it's your price times your quantity. Okay, so you can just, if it's perfectly inelastic, you can just keep setting the price higher and higher, um, and you'll see no consumers leave, right? But if it's perfectly elastic and you raise it even a penny, all your consumers are going to leave, all your customers are going to go away. So price elasticity of demand matters for essentially how much a price change is going to affect your business. Okay, and ideally you want to be in a more inelastic market so that you can increase your price without seeing too much of a hit. Okay, so let's step into the slides. Okay, so why do we care about elasticity? Because it'll tell you how much your revenue will change if you increase your price. And to formally define that, revenue is equal to your quantity sold times your price. If you wanted profits, it'd be quantity sold times price minus costs, or revenue minus costs is your profit. Okay, but seeing as we don't have costs in this, and you can't see cost immediately, we can see revenue on the supply and demand function. Okay, so if you raise prices on an inelastic product, your revenue is going to increase, and let me show you why. Okay, so if we have an inelastic demand, okay, so first let's ask what's on the x-axis. Y'all should be saying quantity. What's on the y-axis? Y'all should be saying price. What's downward sloping? Demand. Okay. Actually, I don't want the demand to look like that. I want a relatively inelastic demand. So I'm going to draw the slope pretty steep. Okay. So this is not perfectly inelastic. This is just regular inelastic that I have right now. Okay. And right now, this is my equilibrium quantity, my equilibrium price. Let's just say that the price is equal to P1. We wouldn't know what's equilibrium because I didn't draw a supply curve. Okay. But right now I'm just giving you that this is the price, and from there you can tell that it's going to intersect with the demand curve here, so this should be your quantity. Okay. And I said that revenue is equal to your price times your quantity, right? Notice also that the area is of this dotted line is going to be price times quantity. And I'm going to say P1, Q1, right? So this area and right here, below the dotted line, what is that? That's your revenue. So let's do green now. So your revenue is captured by this area right here, okay? Price 1 times quantity 1. All right, so you have an inelastic good, and I said the price right now is P1, so you find the quantity is equal to Q1 based on where P1 intersects with Q1 on the demand curve. And you have your revenue here given by the area P times Q. Now, what if I said that the price increased to P2? Okay. Well, and I go to where P2 intersects with the demand curve. And it looks like it's right here. Okay. So Q2. I'll make this revenue 1, and then I'll do thick black for revenue 2. So your revenue 2 is going to be everything from here to here. So everything from P2 to Q2 on this graph, okay? So you increase the price, quantity demand that shifted in, but it didn't shift in by a lot. And just judging by the picture, this area that you gain is much bigger than this area over here that you lost, okay? So Rev 2 is greater than your revenue 1, okay? So if this is like, just to break it down a little bit further, this is B, this is C, and this is A, Rev 1 is A plus B, Rev 2 is B plus C, and C is greater than A. Okay. And why is that? I'm going to shift right over to the text tool because I keep writing words out and it's terrible looking. Change in Q is less than, so downward change in Q is less than your upward change in P, right? That's essentially what the definition of inelastic is, right? Oh, sorry, my head is cutting this off, I realize. Let me bring this bad boy over. Come on, move over. All right. So the downward change in Q, the loss of customers, is less than the increase in price. So if you're selling the good, even though the customers have left, like a few customers have left, you're charging a much higher price. So your revenue is actually going to increase. Okay. Now, what if I gave you a pretty elastic demand curve, an elastic demand curve? So a demand curve that's relatively flat sloped. Okay, so there's your demand, and I say that this is P1 over here. Let's just assume that so that I don't have to redraw it, that it intersects over here. So this is Q1, okay, and then I change the price to P2 up here, and that intersects right there. Okay. Revenue 1 is going to be here. We'll call this A, we'll call this B. And revenue 2, let's do black. Revenue 2 is going to be C plus B. I can barely even draw how small C is, right? Revenue 1 is going to be A plus B. And don't put any stock on what I labeled as A and what I labeled as B. You know, I'm sure it's probably not consistent with what's up here. But basically, I'm just labeling areas, different areas of the graph. So A plus B is equal to your revenue 1. B plus C, this is a C right here. B plus C is equal to your revenue 2. A is much greater than C, as it's drawn here. So for elastic, what does it mean to be elastic? That means there's a high change in quantity demanded from Q1 to Q2, even though there's only a small change in price from P1 to P2. So that means your revenue is going to go down. Okay. So if you raise prices on an elastic product, your revenue decreases. And then lastly, if you raise prices on a unit elastic good, there is no change in revenue. The reason being, your change in price is going to be mirrored by your change in quantity. Okay, so they're going to essentially offset because an X% decrease in quantity is going to be matched by an X% increase in price. Okay, and I just drew it a little neater here so that you can consult that when you're looking at the slides, so you don't have to go by my ugly looking graphs. All right, I think that's it. Yeah. So next up, we're going to be talking about alternative definitions of elasticity, just other things that can have meaningful elasticities. So it's not just price elasticity of demand, but there's other things that matter too.